Hello, hi, good morning, good afternoon. Thank you once again to join another interesting webinar from Securiton. A warm welcome to all the audience today. Without any further ado, we'll proceed with our agenda for today, with our topic, ADW in deep fryers. And those who just joined in, kindly please switch off your microphones and cameras before we go into the session. And today, the main topic that we'll be covering for this webinar will be the ADW in deep fryers, which by we will start with an introduction about deep fryers. We'll start with the deep understandings about the deep fryers and the key components of the deep fryers to understand better, followed by fire codes in practice with the fire standards that applies in order to implement deep fryers and its detection system, followed by ADW solution in terms of deep fryers concerned. And finally, we also will be looking into the project installations of how ADW and its component shall be used in the deep fryers. And I'll close out with the conclusion the entire webinar today. About myself, my name is Satya Seelan, and people address me as Seelan. And I'm with the company for the last 14 years. And basically, I'm taking care of the technical support for Sales International within the organization. And that includes of areas from Southeast Asia, Asia, and certain other countries around the world as well. So mostly all the technical questions will come to us or to me, and then I'll give you the information accordingly. And with that note, let's go into our introduction for today, which is the deep fryers. What is industrial deep fryers? Deep fryers, or the other word we call commercial or industrial deep fryers, it's a deep oil fryer used in many different establishments that requires the frying of various food items in large amounts. And this is also called a deep fat fryers. So what is deep fat fryer? So fat fryers is actually a process during which the food is cooked and actually dried through a contact with the hot oil. So the oil not only serves as a heat transfer medium, but it also absorbs by the food and contributes to a flavor and texture to the product. So there's a process involved from the entire. It's called the deep fat frying. And there's various names can be addressed for such systems. So normally they're also called the deep fat fryer or the fryer-loiter, French fryer, or even the vat fryer. Okay, why is it called the vat? Because there's a multiple vats in it, which is filled with cooking oil, and then it's heated up by the burner and running through a tubes underneath. An industrial type of fryer can be in many forms of operational in terms of temperature is concerned, and mostly it works in a very high temperature range that normally starts from 120 degrees and above. So working in such high temperature environment is actually put high risk in which need to be observed closely. What are the high risks involved here, such as fire, where a proper detection and prevention methods need to be closely monitored or identified in order to make sure that deep frying processes works accordingly. And if there is incident fire, then can be distinguished and suppressed in easy and fast manner. So that's the idea of today. We're bringing this chapter of deep frying and its methods of solution. And with that note, let's look into the types of deep fryers available in the market. So deep frying operations are normally categorized into two groups. The first one is the small types, or the static batch of frying operation, which normally you could actually see in the normal commercials like the KFCs and McDonald's and all whatsoever. So they have a very small scale frying deep frying methods. Whereas we also have the second types of method, which is a large, which works in a continuous frying operation, mostly used in industrial scale, which produces very high volume in terms of the productions or the output of it, and end-to-end product. Because of this number of differences between the batch and the industrial frying operation, the safety and security levels are involved here, because this is not autonomous and it works in the multiple levels of operation. So more components involved, more risk is also involved. So that's other discussion we will look in. What are the components that involved and what are the protections needed for such continuous large amount of operation? In order to understand better about the risk that I mentioned earlier, we have to look into what are the causes of fire in terms of industrial deep fryers are concerned. So we can categorize many of it, but main two categories we will look into is the poor mechanical maintenance and the fryer grease buildup. As you know, thermostat is a malfunction is the primary cause of the deep fryer functions, because that fluctuation or movement is always monitored by the thermostat. And if this thermostat is malfunction, obviously the cooking temperature can rise. That can go above 218 degrees, and the oil start to smoke. The smoke productions will increase as the temperature rises. That causes fire incidents, could leads to a fire incident as well. Another common factors that leads to fire incidents is the fryer's grease buildup. This I'll also explain later in my presentation. In nearly all fryer designs, the gas version, ventilations, or the burner or the oil types, which we are looking into now today, it's behind the valve, which reduces over the time. There's a build-up of residue, which actually becomes a source, the main source, or we can say an excellent fuel source for if it's become if it built up too much in terms of the operation, and this element can be a good source of fire when the temperature rises above its normalities. So, and finally, inadequate maintenance of standards. So no proper records were kept and the repair works were not. So these two things started to happen. The poor mechanical maintenance as the fryer grease built up, both leads to casualties of fire can happen. Just to mention that auto ignition takes place approximately 273 degrees and above if one of these items fail to do the job, with the temperature, a thermostat malfunction, and depending the type of the oil, the amount of impurities that is in use. So this will cause the fire incident. But need to mention here also the new generations or the high temperature fryers are designed to maintain the heats and the oil longer and cook at higher temperature, much close, actually very much closer to the ignition level, which is 273 degrees. So this make more significant fire risk, because the more advancement it is, there is more issues involved in it. So the appliances of the manufacturers should also involved in notifying to the relevant people and standards to be followed in order to make sure this high temperature fryers required an upgrade in terms of detection as well as the fire extinguisher system to cope up such bizarre changes in terms of this operation. Further than this is the main two issues beside causes. If you look into further subdivision of the issues that causes the fire incident would be, for example, as I mentioned about the overheating earlier. Inside the overheating, what we look into here would be the fryer temperature of the control failure. It can also be a temperature control failure of the thermal oil boiler itself, and temperature alarm failure, so it doesn't keep alarm on time, and temperature probe failure. There's a probe inside of it. Most of the systems come with the probes in various part of this of the operational, and one of the probes malfunction can leads to another malfunction and leads to a fire. The extract fan does also failed. So these are the overheating that can cause, if one of this component or multiple components failed, can also lead to the overheating. Besides that, lower or low oil level can also gives higher heating possibilities. That's a failure of the float control built up of sediments, which has also means the residue which is started to build up in front of the chamber or inside the chamber, and eventually also the human failures to detect all these components as well. Okay, with that note, let's look into what are the fire hazards. We have seen what are the issues of fire, and let's look what are the hazards involved with this fire incidents. Obviously, as we work with the high temperature, it's with the oil produced, there will be issues here. What are the issues? One would be the burns. The temperature of the fire oil is usually it's around 250 Fahrenheit, so 117, approximately more than 120, yeah, because we will start working with 120 and above. Anyone who that operates or clean or pass barriers or the workers near suffers a serious burns if it's a flash has happened or if one of the malfunction mentioned earlier happened, and it can cause severe burns on the humans. So when humans are in danger or a factor involved, so a proper detection shall be in place. That's what NFPA is mentioned. So NFPA basic NFPA rules is when humans casualties shall be eliminated. Second, need to be mentioned also carbon monoxide poisoning. So most commercial or industrial types of operational fire deep fryers do contains carbon monoxide. It's actually an odorless, so not many people are aware that the presence of this odorless gas presence. And when something is burnt, typically overburned oil produces CO, carbon monoxide. Not many people are aware of this as well. So commercial fryers have a special vent to help to divert the poisonous gas to the vent hood. But in the event when the vent hood, the ventilation hood or the fryer exhaust is malfunction, so the carbon monoxide can be in the room itself. So it's will quickly fill up the entire area, and that can cause us issues. So what are the symptoms that we have if we have carbon monoxide poisonous? You will have headaches, weaknesses, and dizziness. Eventually, you can have also suffocations. That can happen also. So this too built up to issues with humans in operation when it's concerned in deep fryers application. So with that is in mind, let's look into what are the components that involved in the industrial type of deep fryers here. So basically, as you know, there will be a continuous frying system. That's a huge, long version, depending on the industry and types of food they were manufacturing or being used as a fryers. For example, vegetarian or vegetables or meat and all that have a different types of temperature, different types of settings, and different types of automation levels as well. But basically, these are the major components which involve. Let's look from the right. We will have the main one, which is the oil heater, which is heated up the oil. And obviously before that, we have the PLC control, PLC control, which actually controls the entire events to happen, or programmed to work to tell the systems or to educate the system to work accordingly. That tells the oil heaters to heat it up, and we'll go through through the oil circulation pump, and a continuous filter will work to filter up the residue before going into the continuous frying system, and eventually the input and output. This is not the end process. Yeah? The process will keep going on, whereby the oil tank with cooling systems is also involved to cool up the system, and the temperature rises abnormal, and to normalize those temperature. In order to deep understanding of this component or the process that it works, let me explain in details about how the entire system works. Here, as you can see, the automated continuous frying process system is specially designed to work in continuous process, as the PLC presents, with the high-scale factory manufacturing facilities available. So that includes what are the components: the feeding part of it, the commercial deep fryer, which is the main big component, the continuous filler. And then we also have the oil filtering, the oil circulation, the de-oiling, the flavoring part of it, and finally the cooling part of the system, and which features all fully automatic process, high output process, product by more precise and more efficient in it. And this process will start from the circulation pump, will send the oil to the heat exchanger, and the exchanger heats up and the heat conduction oil from the boiler so that the temperature of the working oil rises about approximately 120 degrees. Again, this depends on the types of materials or types of food is being used. So in normal cases, it starts from 120 up to 190 degrees of operational. Later, the food materials will be placed in inlet feed, okay, in the sink of the oil first. And with the flow of the oil, the materials will be washed under the fryer belt working net. And from there, the underlying driving will net the baffle of the oil flow, the material, and the fried material finally floats inside the continuous fryer, taken out to the exit of the continuous process. See, at the same time, the frying of the filter circulation pump, the working oil will be filtered through the oil filter, and the heating circulation pump intermittently draws the oil from the working oil tank to replenish the working oil. So this is a whole process of working, and we need to be mentioned the oil or the heated oil or high temperature oil will be circulating back and forth to the filter and to the unit. So there is a high risk involved in every corner of this operation. And finally, the deep fryer machines is also equipped with the lifting devices to facilitate cleanings and replacements of the working oil. And in fact, you need to clean this on a routine manner, which is also mentioned in FBA, which I'll be covering soon. So that talks about the cleaning methods and whatsoever not. If not, you will have the residue involved. Then all this will actually causes for fire ignition to happen, or it becomes a fuel for fire ignition to happen. So that's the entire process of how the industrial deep fryers works. So with this understanding of how and what are the components involved, we will be looking into the fire. What does the fire standards talk about the detection system itself? Okay, so if we look into the system, NFPA standards have clearly mentioned, or in 2014 onwards, they were published an updated version of NFPA 96, which is called, which touched on standard fire ventilation control and fire protections of commercial cooking operation. So basically, what does the NFPA 96 is? It actually gives you a guideline. Yeah. So the guideline is safety requirements for commercial equipments and exhaust system. So that can be applied for the type 1 and type 2 of the deep frying systems. I mentioned the commercial type as well as the industrial types as well. So in this NFPA 96, they've derived or mentioned clearly on the design, installation, inspection, maintenance, food specification, and grease removal devices, which is very important to look into, the exhaust duct system, a fire suppression system, and a clearance of the combustible items. So what is our interest today will be on the fire suppression system. We are not looking into the fire suppression system, but we're looking into the detection system that's going to help into the fire suppression system to work on a best optimum level. So further in details about what the NFPA 96 has derived would be two important standards, which I like to share here, would be the clause 10.6, the system annunciation, whereby an automatic fire extinguisher system or an audible alarm or visual indicator shall be provided to show that the system has activated. And second one, where the fire alarm signal system serving as an occupant, serving the occupancy where the extinguisher systems is located, the activation and automatic fire extinguisher system shall activate the fire alarm signal system. So in order to activate, what do we need? We need a fire detection system or a person who detects the early possible fire or smoke and send those signals to the relevant people. So our task today is to look into what could be the best fire detection to work in such bizarre environment. As I mentioned earlier, there are a lot of processes involved. There are lots of uncertainty of oils and temperature that involves for detection. So there should be a detection system works with such environment and temperature. With that note in mind, let's say look into one of the quote that I actually took out from the NFPA, their monthly or yearly annual report. They actually mentioned, according to the NFPS, 21% of the fire that caused in deep fryers, typically due to the lack of cleaning or proper maintenance. And also, at the same time, the NFPA itself, they themselves recommended an annual inspection and service be performed by a qualified commercial cooking appliance contractor. So, or a trained technicians or engineer to handle this. This is due, as you can see in the picture itself clearly, the fryer or the grease buildup as seen in the pictures could lead to the intermittent or a failure of any detection system. So when this grease started to build up in an existing or current probe system, so usually they will use a sensor-based or a proofreading based that can be built up with this grease and can lead to a false alarm. And what the false alarm can lead to a wrong CO2 suppression system being triggered, and unknowingly it is working in a wrong condition. So this is also putting a risk and a downtime for the operation itself. So we have to look into a system that works well and can cope up with such environment as well. Even they fail to do the maintenance, but our system should be able to do a detection. So that's what we are presenting today, or we will look into the system. So, and as I mentioned earlier, from the clause of NFPA, the industrial frying system mostly using fixed temperature and detectors for discharging CO2, as I mentioned earlier as well. However, when this hood is cleaned, the detectors went into a short circuit, or most of the time can be also malfunction, or can also give you a wrong readings. What is a wrong reading will leads to producing a discharge of the CO2 system, and the entire operation has to be stopped to be cleaned. So any discharge of CO2 put a lot of other routines in place. A cleaning shall be done to the entire system. That's a downtime. That's causes a lot of risk factors as well hereby, which means the operation will be halted. At the same time, restructuring the whole thing, cleaning up the entire systems, and to putting up the CO2 back into place will take time. So this is not an easy operation. So false alarm, it's a serious risk as well in terms of the downtime is being concerned. So with that note, we have looked into what is the process involved, where are the components involved, and what are the risk factors is involved. So we are going to look into a system that can work in such different climate environment. So that would be our ADW 535. And before I go into how do we give the solution, so I'll just give you a brief idea what are the systems that we have, or the types of ADW that we have. We have a single type detector or a dual type detector, which means one sensor or two sensor. So two sensor we can also use in different various areas in the deep frying area. One would be on the oil production area, and all in the other sensors can be used as areas where the conveyor belt are involved as well. So we can also use the ADW 535-2 in places where two zones are needed to be covered. In terms of the coverage, we can go up to 115 according to the EN54, or 200 meters according to the NFPA standards. And we can use copper, stainless steels, and other various materials. But in this case, we will normally use stainless steels, or highly recommended used stainless steel. The reasons copper and other types of materials are to be avoided is because they shall have a chemical reactions in the operations of food, or oil intact with the copper. So this shall be eliminated, and stainless steel or SS tube shall be used as the final detection system as well. So with that note in mind, I'll go into the solution that we have on how shall be placed and run the detection system. As I mentioned earlier, various types of sensors, probes, and types of linear heat detection systems are used in such application. But the biggest concern is when they are being cleaned, or they're being cleaned and being on a maintenance routine. They can also be malfunction due to intact with water during cleaning or other types of materials used to clean the system. Whereas in our case, our stainless steels are, in fact, should not be any problem because we are not the types of probe or direct readings of temperature. As you all know, the ADW works in the pressure differences principle, whereby if there is a heat or a fire happens, the heat actually go through a convection, through the process of convection. The pressure sensor detects the differences between and during fire and actually evaluate the pressure differences inside the chamber. So that eliminates the problems of even it is submerged with oil or intact with oil will give any wrong readings, or if a residue would down the time that it has built up grease on it, it will not give you a false alarm because those residues or the grease built up will not hinder the detection system itself. In here to be mentioned, as you can see, we are running a tube which comes with a flexible hose or a hard plastic tube from where the ADW is being kept, and when it reaches the conveyor or the fryer conveyor, and it has to be into a SS tube or a stainless steel tube. There's a conversion between this flexi hose reel and the sensing coil, and eventually we will have a number of coils inside. The reasons we have the sensing coil is because our sensing coil comes with approximately about 5 to 10 meters, and this gives you a large areas of coverage to be covered inside the chamber or where the oil being run or being placed, and the early detection possible can be detected as soon as possible as well. As you know, the ADW is placed elsewhere, and the sensing tube are inside a very hot temperature, which can be between from 120 degree and above, depending on the types of materials or types of fryer they are using. And in this case, there's huge differences where the ADW is and the sensing tube placed. So that put us in a risk of different temperature. How can the ADW distinguish the actual temperature of rice? To solve this problems, we will have an external sensor, which is called ART sensor, will be placed near or somewhere the area of the working conditions to normalize that the ADW knows that its condition exactly is the same with where it is. So with that, he knows the basic value or the base value that you need to be detected. And in case of fire happens, which is the rising of temperature from 120 degree to certain types of degree, which we can do the calculation and it will produce alarm accordingly. So you can also produce pre-alarm, alarm, and also a final alarm as well. So the stages alarm can be programmed inside ADW to do so. In terms of the sensing coil, as I mentioned earlier, the types of sensing coil shall be used would be stainless steel. It's because it's safe to be used in food industry, and there is no chemical reaction that involves with oil. So, and also to be mentioned, even after fire, there shouldn't be a problems in terms of cleaning up or changing the system. So we were looking into a maintenance-free system here. Why we call it maintenance-free system? It's because a melting point of a stainless steel is approximately 1,400 degree to 1,500 degree, which is a huge fire. Even a petroleum fire will not lead more than 900 degree. So this makes it ideal for deep frying application, that we don't need maintenance or rechanging the systems in case of a real fire happens. So as I mentioned, that puts us in a good position whereby our temperature range are quite high, or the range that we can work with will be very high. In terms of where the processor can work, it can work from -30 to up to 70 degree. Okay, and in terms of the temperature sensor, which is the stainless steels running through the detections area, can go from -40 up to 180 degree. In terms of more than 180 degrees, a special modification shall be done in order to, especially in the fittings and other components, to sustain sub-temperature. If such environment is concerned, you shall seek more information from Securiton to give you an insight details about what are the modifications needed in order to sustain if you're working more than 180 degree temperature range. So what we do is, in order to find the issues, as I mentioned earlier, different types of fryers will have different types of operation temperature. That can be within 120, or there are types of fryers that works from 140 and 160 degree and above. So there'll be always a fluctuation during operation, during the maximum types of operation. You see, the temperature rises according to the amount of materials being fried inside as well, and the components used. For example, a meat produces very high temperature compared to a vegetables that we're going through. So that's put us a risk to find out what is the best settings that I'm able to put it in, and to eliminate false alarm, because we know there's a temperature rises up and down and fluctuate according to the operation, whereby we have a data collections possible by the ADW, which is an SD card insert. The SD card can actually record all this information, and this informations we will derive in a graphical formats, and every 1 second of this information is recorded, which means the pressure differences on every 1 second will be recorded, and we will collect this information. And we will see what is the highest peak, lowest peak, and during the operation. For example, we can study for 1 up to 14 days, or even more if you need it, to see what is the optimum level can be used as the best detection system. So with that point, so we will take those informations and we will do the calculation, and the data with the minimum and maximum and the average values that we're able to get, and we'll finally get the mode and standard deviation information, and this we will key into the system. So we know this is the highest peak it can go to, and this is the lowest peak it can go to in a normal operation without a fire incident, and we will get in this information. So we have the flexibility to change our pressure sensors informations, or those information from there, and derive to a very useful information, so we eliminate false alarm completely. So that's the case. See, probe sensors or other types of LHTs available in the market, they only will have a fixed types of temperature, or else a temperature which only works in certain types of range. And if it's out of this range, probably they have to change those detection system or the probes according to the need. So this is it involves a lot of process. Okay, so in order to start a new process line with the new materials of frying, they need to change the detection system 1 time, and second time and third time. In our case, we know the range of the types available. We can do all the settings inside the ADW. We have settings 1, 2, and 3. We have 3 types of settings that can be programmed or can automatically alter from the PC, and we can download anytime. So we do not need to change the probe. Instead, we change the settings, and then it works accordingly. So that put us in a very easy manner. So as I mentioned, we are maintenance free in terms of if there's a real fire, we don't have to change. And now we don't even have to change during the operation, whereby the system able to distinguish by getting all this information, and the right settings can be done. With that, I'll show you some of the projects that we have done and how this coppers were running through on the top of the fryers. Here, as you can look closely on the right, on the left, you can see a copper running, and it's been placed on top of it, where towards the leading of the exhaust. So if any fire or smoke or a huge amount of fire increases inside the flyer, can be detected by the linear type of the stainless steel which is running. And as you can see on your right, there will be a copper coil, stainless steel coil running in a range of in between 1 meter distance. And that will actually, as I mentioned earlier, this coil is it's a 5 to 10 meters of a range, which could able to detect in a very fast manner in terms of the fluctuation of temperature concern. Okay. So the benefits of ADW, as I mentioned earlier, there are quite a number of benefits involved here, whereby we have 1 or 2 types of sensor, or 1 sensor or 2 zone system sensor, which we can also use for the fryers as well as for the conveyor belt detection with using 1 single ADW itself. So as I mentioned, also we have a data logging on an SD card, which is very useful to find out this information, derive and change it according to the needs that needed. Unless others, we need to change the probes or the temperature to work in a different temperature. And we have all the extension modules available, from integrating to any fire alarm systems through using a relay box or our existing Securiton fire panels by a Securi line integration. And we also have a networking system in the case of we have 5 to 6 fryers in the same operational, and you like to change all the setting at the same time, you can connect them in a series of connection through LAN connections or RS485 technology, and we can view in a one central place using the ADW config software. And we can program, reprogram, and also use as a maintenance tool to maintain the system as well. Besides that, we also provide these software tools, which is the heat calc software that could able to do the calculation. As I mentioned earlier, we are looking into a different types of applications, deep fryers. Then we need to know exactly what is the ables. If I run this number of coils and bends, and what is my detection area could be, and what is the fastest detection manner that I have to do it. All this could be answered by using the ADW 535 heat calc or the heat calculator. Good. So with that information, I would also like to mention that in case we're not only looking into one factor here, which is the alarm level, we are looking into a few factors here. We need to alert, as you know, the fluctuation is, we are looking into an operation from 120 degree and above. So a lot of issues are involved. We could actually alert them in a very early manner. There's a pre-alarm state before the alarms is being produced. So we have multiple fire actions here. We have rate of rise alarm, and we call it action, which is the pre-alarm of a rate of rise. And we have a rate of rise, which we can call it as a fire alarm 1. And eventually when it reaches the main alarm or the maximum temperature alarm, which we call it fire 2. So we can distinguish between action, fire 1 and fire 2, which we can able to alert the building there is something going abnormal. Please do the checking, and we can do the flasher to flash on when we reach this fire 2. And we know that it's going very fast, that it reaches fire 2, the suppression system shall extinguish the system immediately. So we have a confirmation level. So compared to the competitors or compared to the other types of probes or a fixed type temperature, they may not have such facilities available to cater for different stages of alarm levels to be produced, and the earliest action possible may not be possible. Okay, that put us at risk. They only have to work on when the fire happens, and sometimes the fire can work or can happen in a very fast manner, because we are talking about temperature ranges from 120 degree and above, which we're looking into a very hard situation here in terms of fire that can happen in a very drastic manner. So with that note, I also like to mention that we have all types of approval for international standard, where we are from Switzerland, where we have to comply with VDS, and that is EN norms we followed, and VDS approved product. And in terms of other states and other countries besides Europe, we will look into the FM approved as well. We are on UL listed as well. And we are also RHS compliant, whereby the system is saved in terms of if you're dismantling and recycling it, it is safe for environment. So all these certifications put us in a level where the system is robust and it has all the certifications to work with all the requirements in global market as well. So as a conclusion, I would like to mention that this is one of the most reliable heat detectors in the market, I would say, as compared to the fixed temperature or a prototype. We are far way better in terms of the early possible heat detection system, and it automated. And as you know, there are various types of alarms can be possible. So this is the fastest responding D2 360 fire, so it can be placed in any way. So the entire stainless steel, as well as the detections area, is in 360 types of fire areas. And it has auto-referencing as well. And as I mentioned, one of the key points, we have multiple alarms, which is rate of rise, maximum, and as well as a pre-alarm of rate of rise, which actually put us in a very good position to detect, to alert, and also to suppress accordingly. And we also have 2 detectors per unit, which I mentioned. You can use one ADW to cover the conveyor belt and the other one on the frying method itself. And we have infinite lifespan. As I said, maintenance, it's practically it's not needed, but according to the NOP standards, we do need a maintenance in every year or every 6 months for such application. With that note, we can actually do a testing to make sure that ADW is still in functional or it is in optimal level. Otherwise, there is no other cleaning is needed on the ADW or the copper, but it's a requirements by the end users to be cleaned. It shall be cleaned, and during the cleaning should not be any problems. Why? Because even it's cleaned with the high pressures and whatsoever with the AD copper, the copper will not have any issues. Why? Because the copper has a strength of about approximately 1 mm, which is quite a strength in terms of sustaining such a high pressure in terms of cleaning. So with all this information about Fryer's application and the benefits from Securiton, I would like to say thank you to all the participants today to attend the webinar. Hope you guys have benefited from the information that I've given for today. Now, I would like to open for any questions.
Seelan, we have a couple of questions, and the first one is, since deep fryers in industries can differ in working temperature ranges, can we still use the ADW for more than 180 degrees?
Yeah, okay, so good question. So yes, of course, we can use, as I mentioned earlier, the working temperature of ADW, it's from approximately -40 up to 180 degree. So when it concerned about more than 180, some modifications need to be done. And this modification is purely on the fittings and other relevance so that they can sustain those temperature and can be used and can be placed. But of course, further studies are needed to study what other factors are involved. But basically, we can work on it as well.
Good. The next question is, when cleaning the fryers with high pressure water, can such high pressure affect the ADW system? Any influence on the system?
Okay, good. So basically, as I mentioned earlier on the last few slides available just now, no, it's not a problem. As we mentioned, the probes or a fixed type temperature, they might be malfunction because they have sensors and microprocessors involved. In our case, it's a tube or stainless tube running in a sort of a compressed air inside or a normal air running inside. And with a high temperature or high pressure, cleaning will not affect. The fact is also it's with an inner and outer diameter of 4 and 5 mm, and it's quite a thick stainless steel which is running through, not able to be spoiled easily. To answer this question, yeah.
All right, so the next question and the last question we have today is, can we place the ADW controller in the same area of the deep fryer?
Oh yes, okay. To answer this question, yes, it's possible, but again, it's always advisable to put it in a weatherproof box or a box which is can sustain such temperature or different. Why? Because to sustain from cleaning processes when during the maintenance, where the flashes of water or high pressure waters can go in towards the ADW, even though our IP is 54, but then it's only splashes of water, not submerging in water. So, and in fact, the working environment also involves of oils, and oil spillings and splashes might happen in that area. So that might not be appropriate. But it's advised, yes, you can be in the same area, but it is advised to be placed in a weatherproof box. Any other questions, Zach?
No, as of now, we don't have any further questions. So if there's no questions, we will be closing the webinar in about 2 minutes. So thank you very much to all of you for attending our webinars. And I've just sent you a questionnaire. It would be appreciated if you could please fill it up for us so we can improve our webinars. The next webinar will be on the 20th of October. That would be ASD data centers. So please join us. And thank you, Seelan, very much, and all of you. Bye for now.
Thank you.